Good. I've also started recording. Most likely my recording would have got corrupted. So please share the recording with me. Okay. So it suddenly exited. Alright. I was under the impression the problem is solved. It doesn't. Alright. So we were talking about measures of center. So you can see that here, this is our average or mean. This is our median. Similarly, income per person case, this is our average and this is our median. So you can see that this median is very close to the peak. Here also the median is closer to the peak. Okay, and therefore generally when you have big enough data, you generally choose median over average. I'll show you why. So you can see here in all these diagrams, the the median is generally close to the peak. Okay, median is generally close to the peak as compared to the average. Okay, so the so you can see here that all right. So one of the biggest reason of using median is stable. Stable in the sense that they don't get impacted because of outliers. Because let's say in our data, suddenly if there is one data point which is say 10,000 times the all other, okay, then suddenly the mean will get impacted. Okay, so median of A. So we have A, okay, and we can say mean of A is 2.7 while median of A is 3. Now what if A got appended by this big data? Okay, what happened? Never mind, it's the same thing. Okay, so when we say mean of A and then we say median of A, now you can see that just because we added one stupid value, one outlier, it changed everything. It changed mean, but it did not impact median. So median is fairly stable measure of center. Okay, it's quite stable to these outliers. Good. Just that for median, you should have good enough data points. Otherwise, median will give you very wrong results. Okay. Now the other thing you should look out for when you look at the data. So what all did we look out? We take the data, we try to first do the scatter plot, and we try to figure out the relationship between x and y. Then we also picked up the data, and against one of the values we did compute the histogram. And then once we computed the histogram, we try to see how the histogram is with respect to the the modalities and skewness, and also we tried to compute the median. Okay, if you say summary A in case of summary A, it shows you what is the minimum, what is the maximum, what is the mean, and what is the median. You see that? All right. All right. Now that was our measure of the center. Now another thing which we want to discuss is the measurement of the spread. Okay, spread means how our data is spread across. All right, is it very close to each other or the data is very much varying? If the Okay, so for example, in a class, are the marks of the student varying too much, or they are very close to each other? So that is the measurement of spread. Or take this case of here, the example which we have been talking about so far. Given that the average life expectancy is 70 and there are 201 countries in the data set, you can compute how much is the variance, how much are people differing from average. So you compute the average and then you subtract the average from each of the values, and then after subtracting from each of the values, okay, you can see that after subtracting you square it and then sum it up and divide by total number of countries. This is called variance. It's represented as s square, which is standard deviation. If you square root this number, we will get the standard deviation. So this is s square is called variance, while s is standard deviation. And how do you compute it? You first find out the average value, okay, and then you square it, and then you subtract average value from all the values, then square it, and then divide by total number of elements minus 1. Let's say we have this a, okay. Now we want to compute the standard deviation of a, or we can say that this is our a, 1 2 3 3 3 3, okay, and we have 4 and 5. See this? So if we say histogram of a, this is how it will look like. Okay, histogram of a would look like this. But if you say standard deviation of a, you can see it's very small. It's very small. Okay, now if we just add a few values in a, as in, let's say there is one value which comes suddenly into called 100. So we have 1 2 3 3 and then 100. Now what is the standard deviation of a? It is has become bigger because the average value, mean value of a is 12.7. Now 12.7 minus 1, then square it, sum it up by 12.7 minus 2, square, and so on up to 100. And that is why standard deviation, or the square root of the variance has increased. Okay, right? When the data points are far away from the median, from average, the data is going to grow bigger, the spread is going to get bigger. Now can anybody tell me, why do we have why do we square the differences? Anyone? While computing the standard deviation, why do we square the differences? Yes, anyone? Why do we square the differences? Anusha, Mehdi? Why didn't we just sum it up by subtracting? Okay, what will happen, instead of squaring, we just subtracted the two values. and then summed it up. Okay, let's try to see. Let's say we have C is 1, 2, and 3. Okay, now our average is, let's say average is how much? Average equals to mean of A. So our average is 2. Now we subtract A with average. We got this value. Okay, we call it difference equals to this. Okay, if we say summation of differences, what do you see? It says 0, which means there is no variance, as in all the values are identical, right? Because the negative positive has cancelled, which we do not want. Therefore, before summing it up, we would like to square it. Okay, and that's the reason why we square it. Now you can see that when we squared the values and summed it up, the the variance was 2. Okay, and that's the reason why we square it. The other reason is we could have done mod means convert negative into positive. We could have done mod, but we are squaring it in order to zoom the difference. Okay, if we square the difference, it is zoomed out, right? It is increased. Therefore, we want to emphasize on the difference. That's why we square it instead of doing the mean. Make sense to you, Anusha and Mehdi? No? Was I able to explain this part? Why do we square the differences while computing the standard deviation or variance? Did I make any sense? No? So my question is everything okay so far, or do you want me to reiterate? Okay, if there is any doubt, any confusion, or the thought is not clear that where we are going, where exactly we are going, what's happening? Yes, Mehdi and Anusha? Okay, so all right, let me repeat. What was I saying is if we do not square, what would happen is negative delta and positive delta would cancel out. For example, here when we said, let's say A, this is our A. We are computing mean of A, which is 2, right? Average of 2. Now we are subtracting this average from every value. This is A. A minus average is this. So we have subtracted 2 from all the values. Now we got minus 1 and 1. If we sum up this delta, we will get 0 because negative difference and positive difference have cancelled out each other. Therefore, without I mean subtracting and summing it up did not give us the right result. Okay, we could have said something like mod. There is yeah, we could have done something like mod, which mod means if some number is negative, we convert it into positive. But again, the problem with that approach, as in doing the mod and summing it up, is that we are not emphasizing on the difference. Okay, that's the reason we do square it. Okay, so you can see that this is the another reason. I mean, we have already written an example. Get rid of negatives so that negatives and positives do not cancel out each other, and and it increase larger deviation more than the smaller ones so that they are weighted more heavily. So as the difference increases, the standard deviation increases faster. Okay, therefore it makes sense to have the standard deviation squared. All right, now there is another question, and we would like to keep these two words very clear. as you go ahead and write your reports about data analysis. Okay, so keep the words very clear. There is a difference between variability and diversity. Okay, while in journalism we use both the things together. Variability means how much is your data varying. For example, you have got set 1 and set 2. Which of the following set of cars has more diverse composition of colors? Which one is more diverse with respect to colors? Anyone out of set 1 and set 2? Yes, Mehdi? Out of set 1 and set 2, which one is more diverse? Anusha? With respect to colors. So the set 1 or set 2? Which one is more diverse? Correct. Correct. Thank you, Mehdi. Yes. So set 1 is more diverse in nature because it has got different colors, while on the right hand side looks really, really boring. All right. Now, next question to you is, which of the following set of cars has more variable mileage? We did one more thing. We marked all these cars with a number. Number represents the mileage of each car. It shows that in set 1 you have 30, 40, 10, 20, 50, while in set 2 you have 10, 10, 10, 50, 50. Okay? So question is, which one is varying more? Where is more variability? Set 1 or set 2? Anyone? Alright. So let's try to answer this question using simple technique. Alright. Let's try to answer this question using simple standard deviation. Okay. So here we are. We have set 1 A equals to, I'm just writing in terms of R. So we have got 30, 40, 10, 20, and 50. And A1 equals to 10, 10, 10, 50, 50. 10, 10, 10, and 50, 50. Okay, so let's just compute the standard deviation of A and A1. Okay, so you can see that the second one, the A1 part here, A1 part, the variability is lesser. Sorry, variability is greater because the users, these things exist far away from the average. Both the sides 10, 10, 10, 10 and 50, 50, 50 is existing far away from the median. Okay, and that's why the second set is more variable. You can see that the data is far away from the center, while in this case some data is closer while some data is far away. And this is what represented by our standard deviation. Make sense to you? Did this example make any sense to you? All right. All right. So the question here was why I was taking this example is, mostly when you look at these numbers and you try to compute variability in the head, you are most likely to go wrong. Okay, so that's why you have tools like R. All right. Tomorrow we will continue from interquartile range. I know this session is going to be really big, and we will go into more and more example tomorrow. All right. So if you haven't done our hands-on based on our yesterday's video, please do so. Also, Mehdi, I think you have recorded the last session's video, and could you just upload it somewhere and give it to me? You give me the whole one. All right. Tomorrow, what time? As in, we will start with 8 p.m. IST. Okay, you can convert 8 p.m. IST to PST, for example. We will start at this time. Okay, we will start at today's time, which was 8 p.m. IST. Okay, so Anusha, could you share the video of today with me? And Mandy, I think you have the video of last session, so share that one also. All right, share that one, not that one also. Okay, we'll continue from here called interquartile range. These are very important definition. Although the concepts are pretty straightforward, very straightforward, just that the definition and getting used to these definition takes a bit of time. All right, great. Have a great day. See you tomorrow. Bye bye. Bye Anusha. Bye Mehdi. Have a great day. Bye.